Alright, in this lesson we're going to talk about stoichiometry. Stoichiometry is the study of chemical quantities in chemical reactions. So in this section we're going to combine our knowledge of chemical reactions and our knowledge of moles. And the way we do that is through the mole ratio. The mole ratio is the comparison of moles of substances in a balanced, that's important, balanced chemical reaction. Okay, so the comparison of moles of substances in a balanced chemical reaction. So just to start with a simple problem, and then we'll build some more difficult problems. According to this equation, nitrogen plus 3 hydrogen make 2 NH3. How many moles of ammonia, and NH3 is ammonia, will be produced if 4 moles of hydrogen react with excess nitrogen? Of course, the term excess means you have more than is necessary. So again, we begin with what we're given, which is 4 moles of hydrogen. Alright, so we're starting with 4 moles of hydrogen. How many moles of ammonia can we make? So our moles of hydrogen we no longer want, so we would put that on the bottom. Our moles of ammonia we would put on the top. Now this is our mole ratio. Now the ratio comes from the balanced chemical equation. That is the coefficients. So for every 2 moles of ammonia, it required 3 moles of hydrogen. Again, those came from the coefficients in the balanced equation. So we would multiply by 2 and divide by 3, and we would determine the number of moles of ammonia. And we get to 2 significant figures, 2.7 moles of ammonia would be our answer. Alright, so pause for a moment and you do the next problem, and then I'll run through it with you. So how many moles of lithium chloride will be formed by the reaction of chlorine with 0.046 moles of lithium bromide? So we have 0.046 moles of lithium bromide. How many moles of lithium chloride? So we want to get rid of moles of lithium bromide, so they go on the bottom, and then moles of what we want, which is the lithium chloride, on the top. And the mole ratio there is 2 to 2. Now we do not reduce our mole ratios, we write them in as 2 to 2, but mathematically we know we're just multiplying by 1, and so since the ratio is equal, the number of moles produced would be equal to the moles that were reacted, since they have a 1-to-1 mole ratio. Okay? So next, converting between grams to moles. So grams of one substance to moles of another. Alright, so in this problem we want to know what mass of potassium chlorate, so how many grams of potassium chlorate is needed to produce 0.5 moles of oxygen. Again, starting with what we're given, 0.5 moles of oxygen. Alright, we no longer want our moles of oxygen, so we'll put those on the bottom. In order to get to grams of potassium chlorate, I must first know the moles. And so we put moles of potassium chlorate on the top. Now what is the mole ratio? We have 3 moles of oxygen for every 2 moles of potassium chlorate. So our moles of oxygen on the top and the bottom, that unit cancels. We multiply across the top and divide by the bottom. So 0.5 times 2 divided by 3. And we get 0.33. And we started with 2 significant figures, so we'll end with 2. And that's moles of potassium chlorate. But we wanted to know how many grams. So now we need to convert that into grams. So 1 mole of potassium chlorate has how many grams? And again, this is what we've been doing the last couple of days. So we add up the mass, 39.1 for potassium, 35.45 for chlorine, and then 48 for the 3 oxygens. and we get 122.55 grams. And so then we'll multiply that times our moles, and we get that our answer is 40 grams. I need 40.0, just a decimal here because I need two significant figures. Okay. Now we can do this just all in one big long fence. So let's look at it that way. So this is one way you can do it, break it down into multiple steps, or we can do it in one long string. So in this problem we're starting with 30 grams of aluminum oxide. Right, so we no longer want grams, so they'll have to go on the bottom, aluminum oxide, and we can convert that to moles of aluminum oxide, because we know we can calculate the number of grams in a mole. So we have 2 times 26.98 for aluminum, plus 48 for 3 oxygens, and that gives us 101.96 grams. And so our grams of aluminum would cancel. Now that we have moles of aluminum oxide, we can use the mole ratio to convert to our new substance. And so we'll put moles of aluminum oxide on the bottom, so that will cancel. Now what's the new substance we want? Moles of aluminum. So we'll put moles of just aluminum on top. And what is that mole ratio? We have 4 moles of aluminum for every 2 moles of aluminum oxide. And so then we'll multiply across the top and divide by what's on the bottom. And so we'd take 30 times 4 divided by 101.96 divided by 2, and we get 0.588 moles of aluminum. And we needed to keep 3 significant figures because we began with 3 significant figures. Okay, so you pause and try this next problem, and then when you come back I'll go through it with you. Alright, so what is the mass of phosphorus? So we're looking for the mass of phosphorus that will be needed to produce 3.25 moles of tetraphosphorus dicoxide. So we have 3.25 moles of tetraphosphorus dicoxide. Alright, I want to convert this into mass of just phosphorus. But before I can get to mass of phosphorus, I need the moles of phosphorus. And so we can find the moles of phosphorus with our mole ratio. So moles of tetraphosphorus dicoxide, we put that on the bottom, so that unit would cancel. And the moles of the phosphorus that we want on the top. Now what's the mole ratio? Well, it says we have 4 moles of phosphorus for every, and then a no number would be an understood 1. Okay, and so our moles of tetraphosphorus dicoxide cancel. Now we have moles of phosphorus, but what we really want is the mass. We're looking for grams. So again, we want to use the molar mass. So moles of phosphorus we put on the bottom, grams of phosphorus on the top, and then we look up on the periodic table for the mass of 1 mole of phosphorus, which is 30.97. Right, and so then we multiply across the top and divide by what's on the bottom. So 3.25 times 4 times 30.97 gives us 402.61. And we allowed 3 significant figures, so that makes it 403 grams of phosphorus. Alright, so one more example. On this one, we're looking at going from grams of one substance to grams of another. And so I do have a new mole town. This one is a better way for you to visualize what we've been doing, and this is on page 10 of your packet. And so in this problem we're going from grams of one thing to grams of another. And so the path we would need to make would be to change our grams to moles, then we cross over using the mole ratio, and then we would convert again to grams of our new substance. Okay, and you can use this to get from anywhere from one mole town to the other. But what connects the two is the mole ratio, which comes from the coefficients of that balanced chemical equation. So let's look at this problem. We have 500 grams of methane. Well, what in the world is methane? Well, I know this is I know this one's water, this one's carbon dioxide, and this one's oxygen. So this one must be methane. And so we get CH4 Alright, so our mole town steps told us first change our grams to moles. And so we're going to put grams of methane on the bottom, moles of methane on the top. For 1 mole of methane, what's the mass? Well, there's 12.01 grams for carbon, plus 4 hydrogens. Each of those are 1.008. And so we get a total of 16.362. And so our grams of methane would cancel. That would leave us with moles of methane, but we want the mass of water. So first, we need to get to the moles of water, right? So now, here's where we are, and we need to get over here to mole center. In this case, this would be moles of water. So this is moles of methane, this is moles of water. Alright, so moles of methane are now on top. To get those to cancel, I put them on the bottom. And I put moles of water on top, because that's what I now want. And so those units would cancel. Now, what's the ratio here? And so what's the coefficient? So the coefficient of water is a 2, and then methane is that understood 1. Alright, but we don't really want the moles of water, we want the mass of water. And so again, we're going to use our molar mass. This time moles of water would go on the bottom to cancel out, and grams of water would go on the top. 1 mole of water has a mass of 18.016. Okay, that's adding our 2 hydrogens, each at 1.008, to our oxygen at 16. Alright, so then we're going to multiply across the top and divide by what's on the bottom. So 500 times 2 times 18.016 divided by 16.362, and then divide by 1 and 1. And we get 1101. So we started with one significant figure. 500, no decimal point, is one significant figure. And so we got this answer. If we want to round it to correct significant figures, then we need one significant digit. And so the 1000 would be our one significant digit. And so this would be 1000 grams of water. Alright, so you try the next problem. And in a moment, I'll run through it with you. Alright, so in this problem we want to know what the mass of acetylene, and this time we told you what acetylene is. So we want to know the mass of that. And then it tells us it will be produced from the reaction of 90 grams of calcium carbide, which is this. Alright, so we're going to start with what we're given, 90 grams of calcium carbide. What's the first thing we want to do? Well, if we look at our mole town, we're going from grams to grams. So we first change our grams to moles. Alright, and so we calculate the molar mass, put our grams on the bottom, and our 1 mole of calcium carbide on the top. Calcium has a mass of 40.08, and carbon, there's 2 of those, at 24.02 would be 64.1. Alright, so now we have moles of calcium carbide. Once we have moles, we can convert to the new substance using our mole ratio. Alright, so moles of calcium carbide now go on the bottom, and moles of what we want, which is the acetylene, go on the top. What's the mole ratio? Well, we have an understood 1 for acetylene and an understood 1 for calcium carbide. So moles of calcium carbide would cancel. Next we want to calculate, though, to the mass. So we are at moles, and now we want to go back to grams. And so this time moles of acetylene would go on bottom, and the mass of acetylene will go on the top. So what's the molar mass? The grams for 1 mole. Well, we get 24.02 for our 2 carbons, plus 2.016 for our 2 hydrogens, and that gives us 26.036